Now let's come to one of the downsides of global warming in the ocean, which we call ocean acidification. And it's to do with the chemical reactions that happen if you move CO2 from the atmosphere into the ocean. So what happens after the uptake of CO2 by the ocean is shown here on the top diagram. It's a chain of chemical reactions. Okay, and the key portion of that is that the end products, one end product is the hydrogen ions, okay? The free hydrogen ions that you can measure. You can measure the concentration by something that we call pH. Okay, it measures the number of these. Not directly, it's a logarithmic relationship, but you can look that up. The other end product is the carbonate ions. Carbonate ions used in skeleton formation. Okay? So, however, this chemistry is not linear. It's not that it's not the case if you increase CO2 in the ocean that you increase both hydrogen ions and carbonate ions. No, it's something different happens. It's an imbalance. What happens is you get more hydrogen ions but less carbonate ions. So it's a shift between two different regimes. It's shown here on the right a little bit, the shift from a more alkaline system to a more acidic system. Okay, in one case you have more carbonate ions, in the other case more carbonate acid. Okay, and this is what happens. The pH decreases under the effect of the human-induced CO2 emissions. Okay, and we can observe these changes. This one is the famous observations at the Mauna Loa station, atmospheric CO2, the CO2 content in the ocean, and the pH decrease in the ocean. Okay, this is what we call ocean acidification. And ocean acidification has a negative impact on species that rely on carbonate ions.